Hello there, and welcome to Deep Space Sleep Channel. I'm glad you're here tonight. Maybe your day has been filled with noise and motion, and now you're looking for a place that doesn't ask anything from you. Or maybe you're someone who finds comfort in quiet wonder, in the soft rhythm of stars that keep shining no matter what happens on Earth. Either way, this moment belongs to you. You don't need to travel anywhere. Just breathe and let the edges of thought begin to loosen. Let your shoulders rest as if gravity itself is rocking you to stillness. Tonight, we're drifting into the Milky Way galaxy, our home in the vast dark, the gentle spiral of hundreds of billions of suns. Circling together through time, we'll move from the glowing arms where stars are born, to the silent halo that holds it all. From the heart of its black hole to the faint edges where light dissolves into night, you'll hear 100 quiet facts, each one simple, steady, and calm. If you'd like, tell me where you're listening from tonight and what time it is there. I love knowing how far these quiet nights travel. Now, breathe slowly. The galaxy has already begun to turn. Let's begin. The Milky Way glows across the night like a faint white river. But that brightness isn't one light. It's the combined shimmer of billions of distant suns, each too far to see alone. Their rays scatter through space dust that softens and blends them, turning sharp light into haze. The band seems to flow because we're inside it, looking through its densest plane from within. That view stretches for tens of thousands of light years, through layers of stars, gas, and silence. When the air is still and the horizon dark, the galaxy's reflection becomes visible even without a telescope, a slow, ghostly illumination written across the sky. In that calm white arc, every glow you see is another world in motion, and every dark rift is dust, hiding still more stars. Together they weave the quiet fabric of home, surrounding Earth in endless, patient light. Long before telescopes or equations, people watched that same faint path and called it the River of Heaven. To some it was milk spilled by gods. To others, the road of migrating souls. No matter the myth, each culture looked up and saw motion in stillness, a current of light across eternity. What they couldn't know was that the Milky Way truly moves, turning once every few 100 million years. Their stories gave meaning to something so immense that only poetry could hold it. The name itself remains our oldest map of the night, proof that even in prehistory, humanity searched for order among stars. If you step outside on a moonless night, you can feel the same wonder they did. The Milky Way is still flowing quietly overhead, just as it always has, bridging every century with light that never needed translation. The Milky Way looks brighter near Sagittarius, because that's where its heart lies. When you gaze that way, you're peering toward the galactic center, a region so crowded with stars that their light overlaps between Earth and that core. Thick clouds of interstellar dust act like soft filters, dimming some light and scattering the rest into a smooth glow. That's why the Milky Way seems fuller, heavier, almost pulsing in that direction. Hidden behind those golden clouds lies a black hole millions of times the sun's mass, but its pull holds the galaxy in perfect balance. Every sparkle near Sagittarius marks another orbit in that grand, slow dance. The brightness there isn't a single beacon. It's the collective shimmer of countless suns circling a silent gravity. Well, what you see as a brighter patch in the sky is simply our view along the densest line of stars, the very heart of the galaxy breathing gently in light. That pale glow comes from light scattered through endless dust and gas. Each tiny grain of carbon or silicate acts like a mirror, bending and diffusing starlight. Instead of a sharp beam, the light spreads outward, forming the faint mist we see from Earth. This cosmic dust isn't dirt or smoke, it's the residue of ancient stars that exploded long ago. Within it float hydrogen atoms, helium, and traces of heavier elements, drifting through space for millions of years. Together they form nebulae that both obscure and create stars, clouds that glow faintly when ultraviolet light strikes them. That soft scattering is what turns the galaxy from a pattern of points into a living tapestry. Through those dusty veils, the Milky Way breathes light and shadow, balancing brilliance and mystery so perfectly that even silence seems to shimmer when you look long enough. Each patch of brightness you notice is not one star, but a vast cluster of hundreds of billions. Within every cluster, suns orbit one another, weaving patterns that will last longer than human history. Some shine hot and blue, born only a few million years ago. Others glow red and dim, ancient and slow, carrying memories of the early universe. Gravity holds them together in calm tension, a balance between motion and rest. From Earth, distance blends them into a single point of light. Yet each point contains countless worlds, some perhaps with skies of their own. When we see that glow, we're witnessing the combined heartbeat of an entire system. It's humbling to realize that even one bright speck in the Milky Way could hold more stars than every grain of sand on Earth's shores, and still, the galaxy carries them all in quiet, eternal grace. That faint silver band above isn't made of continuous light at all. It's millions of distant points so small that their radiance overlaps and merges into one. Every star sends out its own beam, but distance softens those beams into a shared shimmer. The atmosphere blends them even more, scattering blue and green wavelengths so gently that only the white remainder reaches your eyes. That seamless glow is illusion and truth at once, a harmony of individual sparks, becoming one quiet river of brightness. The galaxy itself provides the stage, dust and gas serving as the soft curtain that diffuses the scene. Together, they transform raw starlight into calm luminescence. You're not seeing a single object, but rather the collective hum of countless suns, their light woven together across unimaginable space, turning cosmic noise into silence. You can only see the Milky Way in true darkness, because modern light drowns its whisper. Street lamps and screens scatter photons into the night air, filling the atmosphere with a veil of brightness that overwhelms faint cosmic light. The human eye is sensitive but not invincible. Once the pupil contracts against artificial glow, the galaxy disappears. Out in the desert, far from cities, the story changes. With no interference, your pupils widen, and ancient light finally reaches the retina. The stars return, not brighter, but purer, their pattern unbroken. In that moment, darkness becomes a form of clarity. The Milky Way reveals itself only to those willing to dim the world enough to notice it. When you do, what you see is not emptiness, but presence, a living reminder that light still travels freely through silence, waiting patiently to be found. When Galileo turned his telescope to the Milky Way in 1610, he saw what no one had before. The haze was not a cloud at all, but a congregation of countless stars. His small refractor, no more than a spyglass by today's standards, changed our understanding of the heavens forever. Through it, soft white mist resolved into glittering points too numerous to count. Galileo described it as a congeries of innumerable stars, a revelation that the universe was deeper and denser than any myth had imagined. That discovery ended the idea of a solid celestial sphere and replaced it with infinity itself. What once looked like a smooth brushstroke of light became a window into endless layers of creation. For the first time, humanity realized the night sky was not decoration but architecture, an ever-expanding structure built of light. The silver haze of the Milky Way rests on quiet physics, as gentle as it is precise. Photons, the smallest packets of light, travel for tens of thousands of years before reaching Earth. Along the way, they bounce off dust grains, scatter through hydrogen clouds, and lose just enough energy to soften their color. Each interaction spreads light slightly wider, blending sharp starlight into mist. The human eye integrates these countless arrivals into one continuous sheen. There's no motion we can see, yet every second billions of photons strike your retina, whispering the story of their journey. The brightness you notice is only a fraction of what's truly there, a delicate balance between emission, absorption, and time. What looks still is actually dynamic equilibrium. Light and gravity, keeping eternal conversation beneath the calm we call night. The Milky Way seems colorless to your eyes, yet your mind paints it in shades it can't quite see. Under faint light, the retina switches from cone cells to rods, losing color sensitivity but gaining depth perception. The result is grayscale vision, tuned for subtle differences in brightness. Still, the brain remembers color, filling in faint warmth and blue tone from experience. Cameras reveal the truth. The galaxy glows in pinks, golds, and soft aquamarine dust, hues invisible without long exposure. What you perceive as white is really the blending of all those colors smoothed by distance and memory. In darkness, imagination becomes part of sight. Your mind restores what the eye cannot. So even when the Milky Way looks monochrome, what you feel is full spectrum wonder, an echo of color that lives quietly inside perception itself. The Milky Way's spiral arms are not fixed like spokes, but curve through space like tides frozen in slow motion. Each arm is a wave of density, where stars, dust, and gas cluster more closely before drifting outward again. As the galaxy rotates, these regions of compression move like ripples through water, guiding the birth of new stars, while older ones fade into the background. From Earth, we see them as gentle swirls of light, luminous rivers that trace the shape of time itself. Inside each arm, gravity and momentum find perfect balance, creating the illusion of stillness where everything is in motion. Even the dark gaps between arms shimmer faintly with scattered suns. What seems like calm geometry is a living rhythm, a spiral heartbeat that has pulsed through billions of years, turning quiet matter into order, and order into light. The Milky Way turns once every 230 million years, a span so vast that no single species could ever witness it. One galactic year measures the time our sun takes to complete a full orbit around the center, moving at nearly 500,000 miles per hour, yet never rushing. During one rotation, continents drift, mountains rise and vanish, entire civilizations bloom and fade. From the galaxy's view, these are only moments in its slow, graceful spin. Stars nearer the core orbit faster, those farther out slower, but together they maintain harmony, a cosmic choreography that keeps the spiral intact. What we see as eternity is motion stretched thin, the steady rotation of a disk of light, too patient for human time. The Milky Way's turn is not a race, but a lullaby sung across eons, its rhythm steady as breath. Our sun drifts around the galactic center like a pebble carried by a vast stream. Its orbit lies roughly midway between the core and the edge, balanced between gravitational pull and outward momentum. As it moves, it brings along all 8 planets, thousands of comets, and every trace of our existence, circling a path that repeats once every galactic year. Yet within that immense motion, everything feels still. The constellations we know shift so slowly that only ancient star maps reveal their drift. The solar system's quiet journey reminds us that stability is motion we've grown too small to see. Around us, the galaxy flows on, folding our sun's light into its spiral. Even as we sleep, we're sailing through cosmic current, a silent voyage measured not in miles but in moments of wonder. The Milky Way's shape is defined by its 4 great spiral arms: Perseus, Sagittarius, Centaurus, and Cygnus, each a luminous current winding outward from the galactic core. These arms aren't solid structures but patterns, places where gravity and density converge just enough to ignite new stars. The Perseus arm sweeps near our solar neighborhood, while the Sagittarius arm glows toward the galactic center. Centaurus and Cygnus curl farther out, their clusters shining like sparks frozen in flight. Between them lie quieter spaces filled with dark dust and older stars, bridges of calm connecting brightness to silence. The arms are the handwriting of creation, constantly rewritten as stars are born, die, and form again. Seen from afar, the galaxy would resemble a glowing whirlpool, a vast script of light, spelling out the language of time. The heart of the Milky Way lies along its mid-plane, where stellar density peaks like a glowing seam through the cosmic disk. Here, stars gather in immense numbers, gas clouds collide, and new suns ignite from the compression. This plane is the galaxy's foundation, a balance between the weight of matter and the pull of gravity. Above and below it, stars thin out into the quiet of the halo, but near the midline, the glow intensifies a soft spine of radiance, holding the structure together. From Earth, we look sideways through this crowded region, which is why the Milky Way stretches across our sky like a dense, lumineux ribbon. Within that narrow band, billions of stars overlap, their combined light woven into a single calm brightness. It is the galaxy's center of balance, the quiet axis around which everything turns. The spiral arms glow blue because they are home to newborn stars. Burning hot and young, these stars emit more energy in the blue and ultraviolet part of the spectrum, creating the galaxy's cool-toned shimmer. Their lives are brief, lasting only a few million years, so they never wander far from the places they were born. Within these glowing regions, gas and dust compress under gravity, forming clusters that light up the surrounding clouds. Over time, these same stars will fade into white or red hues as they age and cool, but their early brilliance paints the arms in color. That soft blue light is the signature of creation in progress, proof that the Milky Way is still alive and forming. Each arm becomes both nursery and monument, a moment frozen between birth and decay, written in the quiet light of new suns. Dark streaks cutting through the Milky Way's glow aren't empty, they're dust lanes, the living skeleton of the galaxy. These dense ribbons of carbon and silicate grains trace the spiral arms, marking where gravity gathers material for new stars. Against the bright background, they appear like shadows across a river of light, but within them lies potential energy waiting to ignite. Infrared images reveal that these lanes are warm and full of hidden life. Glowing faintly where starlight filters through, they act as both barriers and bridges, shaping how gas flows through the galactic disk. Without them, the spiral pattern would unravel into chaos. Each dark vein is a reminder that even silence has structure, and that what looks like absence often holds the blueprint of creation, the invisible architecture guiding the galaxy's slow, luminous breath. Before humanity could see the Milky Way's full shape, we had to listen to it. Radiotelescopes, tuned to the faint emission of hydrogen at 21 centimeters, mapped what light could not. This wavelength passes through dust that blinds optical eyes, revealing the spiral arms and distant clouds hidden behind them. As astronomers scanned the sky, they discovered that gas in the galaxy moved in complex patterns, rotating faster near the center and slower toward the edge. These radio signals built a picture line by line, showing that our galaxy is a barred spiral seen from within. The invisible became visible not through sight but through sound, the quiet hum of hydrogen whispering across space. Every signal collected on Earth is ancient, sometimes tens of thousands of years old, carrying the echo of a galaxy that sings softly in frequencies no human ear could ever hear. The Milky Way is layered, like time itself, a thin disk and a thick one, each holding its own story. The thin disk, where our sun resides, is home to young stars, bright gas clouds, and ongoing creation. It stretches roughly 1,000 light-years deep, glowing with the blue-white tones of recent birth. Above and below it lies the thick disk, populated by older, dimmer stars formed when the galaxy was young. These ancient suns drift farther from the center, their orbits tilted and slow, marking a calmer era in the galaxy's past. The two layers overlap, but never blend completely. One breathes youth, the other memory. Together, they record billions of years of change, a cross-section of cosmic history carved into light and shadow. When you gaze upward, you're looking through both the present, shining through the quiet patience of the past. The Milky Way moves not only through visible space, but through an unseen ocean, the dark matter halo that surrounds it. This invisible mass, outweighing all the stars combined, exerts a silent drag that shapes the galaxy's motion. Every orbit, every spiral, every gentle curve follows the pull of something we cannot see. Dark matter doesn't glow or absorb light. It reveals itself only through gravity's touch. It holds the outer stars in place, preventing them from flying away as the galaxy spins. Without it, the Milky Way's edges would scatter into nothing. Scientists still don't know what dark matter truly is. Perhaps exotic particles, perhaps something stranger, but its presence is certain. The galaxy glides through it like a fish through water, feeling its pressure, but never glimpsing its form, moving in quiet partnership with the unseen. At the heart of the Milky Way lies Sagittarius A, a black hole 4 million times the mass of the Sun. It sits quietly in the constellation of Sagittarius, hidden behind curtains of dust and gas. To the eye, it's invisible, but radio waves and X-rays reveal its presence, a compact region where gravity folds space so tightly that nothing can escape. Around it, stars whirl like sparks circling a drain, tracing invisible lines of force. This monster anchors the entire galaxy, keeping its rotation in balance. Yet, despite its mass, it doesn't consume everything nearby. It waits, patient and silent, until drifting matter wanders too close. Then, in a flare of heat and radiation, it feeds. The cause calm isn't emptiness, it's equilibrium. In the darkness of Sagittarius A, gravity and light negotiate the boundaries of existence, forming the galaxy's beating, invisible heart close to that hidden center. Stars move at speeds once thought impossible, some complete full orbits in just a few years, racing around the black hole like comets around an unseen sun. These stars, known as the S cluster, act as cosmic test particles, tracing the shape of space itself. Their paths bend and stretch in response to the black hole's immense gravity, offering a direct view of motion where time itself slows. Observing them required decades of patient measurement. Tiny shifts captured by infrared telescopes piercing through the galactic dust. What they revealed was astonishing, not chaos, but order in motion, each orbit stable, elegant, and perfectly curved. These stars dance on the edge of eternity, their light flickering through the black hole's gravitational lens. What seems violent from afar is actually a delicate choreography. The quiet music of mass and motion intertwined, those racing stars did more than surprise astronomers. They confirmed Einstein's prediction that gravity bends space and time together. When light from a star passes near the black hole, it curves around it, its wavelength stretching as it escapes. This effect, called gravitational redshift, was measured for the first time near Sagittarius A, matching Einstein's equations with astonishing precision. The orbits themselves also precess, slowly shifting their orientation in the way general relativity describes. The fabric of space-time isn't flat, it warps gently around mass, creating the cosmic geometry that shapes everything we see. Watching these stars is like seeing theory turn to truth, mathematics becoming motion. Einstein once said, "Imagination is more important than knowledge." Here, the two met in perfect alignment, proven by a sky that curves and folds as softly as light itself. Gas clouds near the galactic center spiral inward like smoke drawn to a flame. As they fall, friction and magnetic turbulence heat them to millions of degrees, causing them to shine brightly in X-rays before vanishing. The process is slow and graceful, not the sudden swallowing often imagined. Each wisp of gas circles countless times, flattening into a disk that glows with eerie calm. These accretion disks are the last visible trace of matter before it crosses the threshold into darkness. Occasionally, a flare erupts when a fragment of gas is torn apart, its light traveling across the galaxy as a brief pulse. To observers on Earth, these flashes mark the heartbeat of Sagittarius, a bursts of energy from material surrendering to gravity. What disappears feeds the stability of the whole, turning destruction into balance, light into silence. Beyond that glowing disk lies the event horizon, the boundary where even light cannot return. It isn't a surface, but a region where escape becomes impossible. The final line between visibility and the unknown. Inside it, physics as we know, it stops making sense, space and time trade places, and all paths lead inward. The event horizon is small by cosmic standards, only about the size of Mercury's orbit. yet it commands the structure of an entire galaxy. No signal or reflection emerges from within. Only the faint echo of infalling matter reveals its edge. Astronomers captured its shadow through radio interferometry, mapping light bent around the void. What they found was not emptiness, but form a dark ring framed by glowing plasma. It is the universe's quiet punctuation mark, a place where light pauses forever. Sometimes the heart of the Milky Way flickers with sudden bursts of X-rays, pulsing like a heartbeat from an invisible creature. These flashes are signals of matter falling too close to the black hole, heated to millions of degrees before it vanishes. The radiation rises and fades in rhythmic waves, sometimes minutes apart, sometimes hours. As if the galaxy itself were breathing, each flicker carries the story of gas being torn, compressed, and swallowed. To us, they appear as distant glimmers detected by orbiting telescopes, tiny tremors of unimaginable power. Yet there's beauty in that violence. The energy released fuels the surrounding space, keeping the galactic core alive. Even in darkness, the universe whispers that creation and destruction share the same pulse. Those faint, steady heartbeats are the Milky Way's reminder that silence is never truly still, only waiting between moments of light. Around the black hole, magnetic fields twist and curve like silk threads in wind. These invisible lines of force shape how matter moves, guiding gas into spirals and jets. As plasma whirls, it drags magnetic fields with it, creating vortices that channel energy across space. The fields align and break apart, releasing bursts of radiation that flicker like embers caught in cosmic breath. Though they cannot be seen directly, their influence is everywhere in the structure of the accretion disk, in the paths of electrons, in the sculpted light that reaches us. These threads bind chaos into pattern, weaving an unseen fabric through the galactic heart. To watch their effect is to glimpse the galaxy's nervous system, delicate, dynamic, endlessly self-renewing. Each twist of magnetism writes the choreography of matter, ensuring that even the most powerful forces move with grace. Stretching outward from the galactic core is the bar Ardense, glowing bridge of stars and dust-feeding material toward Sagittarius A. It's the Milky Way's internal artery, funneling gas inward while maintaining the spiral's shape. The bar's stars orbit in elongated paths, creating a bright central beam when viewed from above. This structure acts as both conveyor and anchor, balancing gravitational pulls from every arm. Without it, the galaxy's core would starve, and the outer disk would drift apart. Infrared observations reveal how gas streams along the bar, condensing near its tips where new stars form. The bar is not static, it slowly rotates, steering the rhythm of the entire galaxy. Like a tide moving through light years, it connects creation and consumption in one endless flow. Within its calm symmetry lies purpose, a luminous bridge sustaining the heartbeat of the Milky Way itself. Through the densest dust of the galactic center, visible light fades completely, yet infrared telescopes see through. Their longer wavelengths slip between dust grains, revealing thousands of hidden stars that optical instruments miss. These stars orbit the black hole in elegant ellipses, some racing at speeds of thousands of kilometers per second. Infrared imaging allows astronomers to track them year after year, mapping the core's structure with exquisite detail. In this deep red glow, the galaxy's secrets unfold, clusters forming near the bar, gas streams bending toward the center, flares of energy flickering at the edge of darkness. What once appeared empty now overflows with movement and light. The Milky Way's heart, invisible for centuries, becomes visible through patience and technology. Every pixel of those images is a whisper from the core, proof that even the most obscured beauty only asks for a gentler kind of vision amid this swirling chaos of dust, radiation, and gravity. The core of the Milky Way keeps perfect rhythm. Every orbit, every flare, every magnetic tremor falls into harmony, as if tuned by invisible hands. Stars that race close to the black hole return predictably. Gas streams follow measured paths, and bursts of light recur like breath. What seems violent is actually balance, a self-regulating system sustained by gravity's deep intelligence. Even time bends smoothly here, slowing near the center, yet never stopping. The galaxy's heart doesn't beat erratically. It keeps time for everything around it, anchoring billions of stars in quiet coordination. If you could listen closely, you'd hear it not as noise, but as pulse, the steady hum of creation maintaining order in vastness. In that serene precision lies the truth of the cosmos: motion without haste, power without sound. The halo of the Milky Way stretches far beyond the visible stars, forming a vast, dim sphere that surrounds the galactic disk. It extends for hundreds of thousands of light years. Far past the glowing arms we can see, this halo contains not only ancient stars but also clouds of gas so thin they barely shine, remnants of the galaxy's earliest days. When we look up at the night sky, the halo remains hidden because its light is too faint, scattered across too much space to register in our eyes. Yet it defines the Milky Way's true shape, not a flat disk, but a shimmering globe of matter and gravity. Every visible star is suspended within this greater halo, orbiting like dust within a glowing bubble. The next time you see the Milky Way's band, remember, it's just the bright skin of a much deeper cosmic body surrounding us all. Beyond the light of its stars, the Milky Way hides an enormous secret. Most of its mass is dark matter. This invisible substance neither emits nor absorbs light. Yet, its gravity binds the galaxy together. It outweighs all the visible stars, planets, and gas combined, filling the halo like an unseen ocean. Astronomers discovered it by noticing how fast stars orbit far from the center. They move too quickly to be held by visible matter alone. Something massive and silent must be there, shaping every rotation, holding every arm in place. Though no one knows what dark matter truly is, it serves as the galaxy's framework, the invisible skeleton that gives it form. Without it, the Milky Way would fly apart. The unseen outweighs the seen. And in that truth lies a quiet mystery, that the universe is held together by what cannot be seen at all. Drifting through the Milky Way's halo are globular clusters, ancient gatherings of hundreds of thousands of stars packed tightly into luminous spheres. From Earth, they appear as small, shimmering knots on the edge of darkness, like suspended lanterns from the galaxy's youth. Each cluster moves independently, orbiting the galactic center far beyond the spiral arms. Their stars are old, metal-poor, and stable, glowing softly in amber and red. Some clusters may have formed before the Milky Way itself, remnants of smaller galaxies absorbed long ago. Together they form a scattered crown around the galactic disk, marking the boundaries of our cosmic home. They drift in silence, each a miniature galaxy bound by gravity. their orbits slow and graceful. In a universe defined by movement, globular clusters endure like still moments in time, gentle reminders that not everything ancient fades. Some simply choose to drift in peace. Inside these globular clusters live the oldest stars known to science, stellar fossils from the dawn of the cosmos. Many of them are more than 13 billion years old, born when the universe was young and the first elements were forming. They burn dimly now, small and stable, their fuel nearly spent, but their endurance unmatched. Studying their light is like reading the oldest diary in existence. The chemical fingerprints reveal what the early universe was made of. These stars carry memories of hydrogen untouched by heavy metals, a signature of an age before planets or life. They have witnessed the slow evolution of galaxies, the merging of systems, and the birth of new generations of stars. In their quiet persistence, they remind us that longevity is its own kind of brilliance, that even fading light, when it lasts long enough, becomes eternal. The orbits of these globular clusters act like tracers in the night, outlining the gravitational shape of the Milky Way as they move through space. Their paths reveal how mass is distributed throughout the galaxy, visible and invisible alike. Astronomers track their slow motion over decades, mapping how gravity bends their routes, how dark matter pulls at their course. Each orbit is a line drawn in time, a soft echo of the forces holding everything together. The clusters swing far above and below the galactic disk, then return again, completing cycles that take hundreds of millions of years. Through them, we can see the galaxy's hidden fingerprint, a pattern of gravity woven into space itself. Their motion proves that even at the edge of light, order persists. The Milky Way's invisible hand guides them with care, steady as breath across eternity. The halo may hold the secret to the universe's missing mass, the unseen matter scientists call the cosmic discrepancy. When astronomers calculate how much normal matter should exist based on the Big Bang's early light, the numbers never quite add up. Somewhere, much of it is hidden, not gone, just invisible. The Milky Way's halo could be the key. Within its vast emptiness, faint gas and dark matter mingle, forming reservoirs of unlit material that outweigh the galaxy's visible body. Sensitive instruments detect whispers of this mass through gravitational pull and X-ray glow, clues that something immense surrounds us. If confirmed, the halo becomes more than a border. It's a vault holding the missing pieces of creation. The stars we see are only the surface of a much larger presence, a quiet reminder that what's invisible often carries the greatest weight in the cosmos, stretching far beyond the Milky Way's bright disk. Faint gas streams weave connections between our galaxy and intergalactic space. These filaments of hydrogen flow like cosmic rivers, linking galaxies in an unseen network. Some are remnants of ancient mergers, trails of material torn free during collisions billions of years ago. Others are bridges of gas drawn out by gravity's pull, feeding fresh matter into the galactic halo. They move slowly, almost imperceptibly, yet they sustain the Milky Way's growth, replenishing its fuel for star formation. Radio telescopes can trace their gentle arcs across the sky, revealing patterns too vast to comprehend. Through these invisible threads, our galaxy exchanges matter with the universe, breathing in and out across cosmic time. The streams remind us that the Milky Way is not an isolated island, but part of a flowing system, a living current in the ocean of space. Within this invisible web of matter and gas, Dozens of small satellite galaxies orbit the Milky Way like companions to a giant. They are faint, irregular, and ancient, some barely holding a few million stars. Their paths are dictated by the galaxy's deep gravitational field, looping and twisting through the halo in elegant slow motion. Over time, some are torn apart, their stars stretched into tidal streams that merge with our own. Others survive as tiny but complete systems, still forming stars in quiet isolation. These satellites act as messengers of the past, remnants of the Milky Way's early history and its many collisions. Their movements reveal the shape of the dark matter halo that binds them. Each small galaxy is both a fragment and a witness, orbiting within the unseen framework that unites the Milky Way with the vast structure of the universe beyond. At the edge of this vast halo, two luminous clouds drift in perpetual motion, the Magellanic Clouds, our galaxy's nearest companions. The large and small Magellanic Clouds are dwarf galaxies caught in an eternal dance with the Milky Way's gravity. Their orbits tug streams of gas behind them, forming glowing trails visible in radio light. These clouds are nurseries of star formation, filled with young clusters and nebulae that shimmer like cosmic embers. As they circle the Milky Way, they exchange matter and energy, shaping the halo's outer layers. In millions of years, they may merge fully, their stars dissolving into our own galactic disk. For now, they drift along the boundary like partners in a slow waltz, illuminating the dark outskirts of our home. Their motion tells a story of connection of galaxies bound not by touch, but by gravity's quiet embrace. Every faint star wrapped in a haze of interstellar dust belongs to this grand shell, the outermost skin of the Milky Way's halo. These lonely stars drift far from the crowded spiral arms, glowing weakly against the deep black of space. Their light travels for hundreds of thousands of years before reaching us, softened and scattered by fine grains of cosmic dust. Each one carries traces of the galaxy's distant history, forged in earlier generations of suns. The dust around them acts like a memory, the ashes of old stars that once burned bright. Together, they form a diffuse sphere that marks the Milky Way's edge, blending almost seamlessly into intergalactic night. When seen through sensitive instruments, this shell glows faintly, a soft veil surrounding the galaxy. It is the final whisper of light before true darkness, the quiet border where our home meets the infinite beyond. Nebulae begin as enormous clouds of cold, molecular gas drifting through the galaxy, invisible until gravity begins to pull them inward. As the gas collapses, density rises and temperature climbs, forming knots that will one day ignite into stars. These regions can stretch for light years, cradling hundreds of potential suns at once. From Earth, they appear as faint, glowing veils, pinks, blues, and greens painted across the dark. Within them, turbulence stirs, magnetic fields twist, and tiny fragments begin to spin. Over millions of years, each fragment gathers mass until its core compresses enough for fusion to begin. A star is born quietly, not with explosion but with light. The nebula that once hid it becomes a cocoon of reflection, scattering its first rays back into the cosmos. In that glow, creation continues a slow rhythm of collapse, ignition, and radiance unfolding without sound. Among the many nebulae scattered through the Milky Way, the Orion Nebula shines as one of the nearest and brightest, a single cradle among billions. It lies about 1,300 light-years away, visible even to the naked eye as a soft blur in Orion's sword. Inside, thousands of newborn stars illuminate clouds of hydrogen and dust, shaping filaments and ripples that look almost alive. The trapezium cluster, a group of hot young stars at its heart, powers the nebula's glow, carving tunnels of light through surrounding gas. What we see as beauty is actually turbulence frozen in motion, gravity and radiation sculpting the raw material of future worlds. In this one region, the process of creation is close enough to witness a reminder that star birth is not rare or distant, but continuous, happening quietly all around the galaxy, even as we sleep beneath its light. At the center of every newborn star, hydrogen atoms fuse into helium, releasing radiant energy that will shine for billions of years. This process, called nuclear fusion, begins once gravity compresses a forming star's core to extreme temperatures and pressure. The atoms collide so fiercely that they merge, converting tiny amounts of mass into vast amounts of light, according to Einstein's equation. Energy equals mass times the speed of light squared. The result is a perfect balance, inward gravity held at bay by outward radiation. Every sunrise, every beam that reaches Earth, traces back to this silent reaction deep within stellar hearts. Fusion is the universe's simplest and most profound act, taking what is small and making it luminous. In the Milky Way's great engine, it happens in countless stars at once, transforming ordinary gas into the quiet brilliance that fills our night sky. The spiral arms of the Milky Way are not just patterns of stars, they are vast star-making engines. As density waves move through the galactic disk, they compress gas clouds, triggering new bursts of formation. Like ripples in a pond, these waves travel slowly, leaving behind trails of luminous newborn clusters that trace the spiral's graceful curves. Massive stars ignite quickly, shining blue-white against the backdrop of dust and gas, while smaller ones take shape more quietly, destined for long, steady lives. The arms themselves are ever-changing, a dynamic assembly line of creation and renewal. In these regions, the galaxy regenerates, consuming old matter and releasing new light, recycling the ashes of ancient suns into tomorrow's constellations. When we look up at those glowing arcs, we're seeing the Milky Way in the act of building itself, forever creating beauty from gravity's gentle pressure. Dust, though small and silent, gives the Milky Way its warm golden glow. Tiny grains of carbon, iron, and silicate float through space, scattering light unevenly. Blue wavelengths are absorbed or redirected, while red and yellow slip through, tinting starlight with softness. This filtering effect is why the galaxy appears amber along its central band. Each particle of dust is a relic of former stars, material cast out by supernovae, cooled and condensed into grains that drift for millions of years. Together they form the haze we call interstellar medium, shaping the color and mood of the night sky. When starlight passes through these clouds, it becomes gentler, turning sharp brilliance into quiet radiance. Without dust, the galaxy would be harsh, unfiltered white. Instead, it glows like candlelight through smoke, every shade of gold, a whisper from stars long gone, yet never fully lost. Reflection nebulae are among the gentlest sights in the cosmos, shimmering with light that is not their own. These delicate clouds of dust and gas lie close to bright stars whose radiance they scatter, turning invisible particles into veils of blue. The effect comes from tiny dust grains reflecting short wavelengths more efficiently than long ones, much like sunlight scattered through Earth's sky. The nebula itself emits no light. It simply borrows what nearby stars give. Seen through a telescope, these clouds appear like soft brushstrokes of color suspended in darkness, fragments of light painted across night. Each glimmer is proof of proximity, a quiet partnership between dust and flame, presence and echo. Reflection nebulae remind us that even what cannot shine on its own can still glow when touched by light. A cosmic mirror teaching that beauty often begins with borrowed brilliance. Emission nebulae, by contrast, shine with their own fierce glow, a steady pulse of hydrogen-red light born from heat and energy. In these vast clouds, ultraviolet radiation from nearby stars strips electrons from hydrogen atoms. When those electrons fall back into place, they release photons of deep crimson eye, giving the nebula its signature hue. Each glowing region marks a furnace of creation, a stellar nursery radiating with life and transformation. Through telescopes, these nebulae bloom like roses of fire against the black canvas of space, their filaments twisting and flowing as if alive. Their light travels across thousands of years, carrying the energy of newborn suns to distant worlds. What you see is not static beauty, but motion slowed to stillness, waves of gas forever reshaping themselves, teaching that in the universe, even chaos finds a way to become luminous. Inside the dark clouds of the Milky Way, future suns sleep in silence. These dense molecular regions are cold, thick with gas and dust, and almost completely opaque to visible light. Within them, gravity quietly gathers particles together, forming dense cores that will one day ignite. The process takes millions of years, too slow for the human mind to witness, yet always underway. Radio and infrared instruments reveal faint glows and outlines of what will become stars, embryos of light growing in shadow. These clouds drift gently through the spiral arms, their silence, not emptiness, but preparation. The energy of countless generations rests within them, waiting for a small disturbance to awaken fusion. In every hidden pocket, tomorrow's constellations are forming unseen. The calm darkness we mistake for nothingness is actually a cradle holding the faint heartbeat of stars not yet born. When a massive star reaches the end of its life, it dies not quietly, but as a supernova, releasing shock waves that ripple across space. These waves compress nearby clouds of gas, igniting the next generation of stars. The death of one sun becomes the spark of many more, recycling cosmic material in an endless loop of renewal. Elements forged in the dying star's core: carbon, oxygen, ions scatter outward, seeding the galaxy with the ingredients of planets and life. In distant nebulae, astronomers can trace these shock fronts as expanding shells of glowing gas. Still moving centuries after the explosion, they carry the fingerprints of both destruction and creation, proof that nothing in the universe truly ends. Each supernova writes a brief, brilliant note in the Milky Way's eternal rhythm, reminding us that even endings are just transitions into new light. Creation in the galaxy never truly stops. It simply changes its rhythm. Stars are born, shine, and fade, while their ashes seed the next generation. Gas cloud drift, collide, and condense again. Gravity and radiation take turns conducting this quiet symphony, ensuring balance between birth and decay. To human eyes, The process seems still, but over cosmic time, it's a constant dance expansion, collapse, and renewal woven into the Milky Way's spiral. The same atoms that once burned in ancient stars now reside in our bodies, our oceans, our breath. The galaxy recycles itself endlessly, each moment both ending and beginning. Even silence plays its part, holding the pauses between creation's notes. When you look up at the night sky, you're seeing a snapshot of motion too vast to perceive, a universe composing itself in slow, endless harmony. Our sun rests within a small offshoot of the Milky Way known as the Orion Arm, a modest spur between two of the galaxy's grander lanes, Sagittarius and Perseus. It's a quiet neighborhood compared to the crowded galactic core, filled with open clusters, gas clouds, and gentle spirals of dust. Here, space feels calm, balanced between the bustle of star-forming regions and the stillness of interstellar dark. The Orion Arm stretches for thousands of light years, winding like a golden thread through the galactic disk. Within it, our solar system drifts serenely, carried along in the Milky Way's rotation. Though it may seem ordinary, this region is rich with beauty. The Orion Nebula's glow, the Pleiades' shimmer, and the soft dust lanes that give starlight its warmth. It is a small but luminous corner of the galaxy, perfectly suited for life to look outward and wonder. From our quiet place in the Orion Arm, the Sun sits about 26,000 light-years from the galactic center. That distance places us in a sweet middle ground, not too close to the violent energy of the core, not too far into the cold halo where stars grow scarce. Light from the center takes 26 millennia to reach us, crossing spiral arms and interstellar dust before touching Earth. It's a humbling thought. Every time we gaze towards Sagittarius, we see the galaxy as it was before human civilization began. This positioning offers stability, the calm of cosmic suburbia, where gravitational forces balance and life can endure. The Sun's orbit traces a gentle path through this space, steady and slow. Each sunrise is a reminder of our motion, our endless journey around a center we'll never see yet always. Circle patient passengers in the Milky Way's quiet current. Our solar system's path around the Milky Way takes roughly 230 million years, one complete galactic year. During a single orbit, the galaxy itself evolves. Stars are born, others fade, and spiral arms shift their graceful arcs. The dinosaurs saw a different night sky than we do. The continents and constellations both drifted since the last time Earth passed this point in its long circuit. The Sun moves at nearly 500,000 miles per hour. Yet from our perspective, the motion feels eternal stillness. Everything we know, every ocean, mountain, and breath travels together through that vast loop. It is a journey too immense to finish. Yet we are always in motion. The galaxy's spin is our unseen rhythm, a celestial heartbeat marking ages rather than moments, keeping time for life, unfolding quietly beneath its turning stars. Around the Sun, countless stars move with us, sharing the same general orbit through the Milky Way. This cluster of motion forms what astronomers call the local standard of rest, a kind of stellar stream carrying our neighborhood along. Nearby stars, though scattered across light years, drift in parallel paths. Like leaves on the same current, they rise and fall slightly above the galactic plane, weaving through regions of dust and gas. Some are older and dimmer, others bright and young, yet all participate in the same cosmic flow. From our vantage point, constellations seem fixed, but over millennia they slowly reshape, reflecting the steady drift of this shared voyage. We are not standing still under the stars, we are moving with them. Bound by gravity to an unseen harmony, our neighborhood is not static. It is a quiet river of suns flowing through the galaxy together. The closest of our stellar companions lies just beyond imagination's reach, Alpha Centauri, a system of 3 stars about 4 light-years away. To the naked eye, it appears as a single point of light, but through telescopes it resolves into 2 bright suns orbiting each other, with a third faint red dwarf circling farther out. One of these stars, Alpha Centauri A, resembles our own sun, warm and stable, while Proxima Centauri hosts planets that might one day invite exploration. Light from this system takes over 4 years to arrive, meaning we see it as it was in the recent past. Between us stretches emptiness, yet the distance feels like potential rather than isolation. Alpha Centauri glimmers as a promise in the dark proof that even across unimaginable space, other stars still shine close enough to remind us we are not alone. Surrounding our solar system is a vast region known as the local bubble, an enormous cavity in space carved long ago by ancient supernovae. When massive stars exploded millions of years ago, their shock waves swept away nearby gas, leaving a hollow pocket of hot, thin plasma, roughly 1,000 light-years wide. Within this bubble, our sun drifts near the edge, surrounded by walls of denser material, glowing faintly in X-rays. The bubble's interior is calm now, a quiet remnant of past chaos, its boundaries traced by other interstellar clouds like the local fluff and Loop 1. It serves as both shelter and scar, proof that even emptiness has history. We live inside the aftermath of stellar death, yet that void provides the clarity through which starlight reaches us. The local bubble is not absence, its memory the soft echo of explosions that once reshaped our sky. Just beyond the heliopause, where the solar wind gives way to interstellar space, drift the cool, slow-moving clouds that define our neighborhood's outer edge. These clouds, thin, transparent, and ancient, float through the galaxy like fog through a valley, shaped by magnetic fields and stellar winds. The sun's influence weakens there, its charged particles meeting the neutral atoms of interstellar gas. Instruments aboard distant probes detect the change, a shift in temperature, density, and direction of flow. Beyond lies true interstellar space, where material from countless supernovae mingles in a delicate balance. These clouds move gently, neither chaotic nor still, carrying whispers of heavier elements, forged in vanished suns. They remind us that even the emptiest space is filled with motion, connection, and quiet exchange, a boundary not of separation but of blending, where the solar wind exhales into the galaxy's vast, waiting breath. Voyager 1 and 2, launched decades ago, now drift beyond the sun's reach, the first human-made objects to enter interstellar space. Each carries a golden record of Earth's sounds and images, a message to anyone, or anything, that might find them. They no longer send photographs, only faint pulses of data across billions of miles. Their signals take more than 20 hours to reach us, crossing the heliopause into the space between stars. Out there, sunlight is a memory, and silence reigns. Yet both voyageurs endure, powered by the last warmth of their generators, moving about 1 million miles farther every day. They are the galaxy's quietest ambassadors, proof that curiosity itself can travel endlessly. Someday, their messages may fade completely, but their motion will continue, two small relics of human wonder, floating forever through the night between suns, across the emptiness between stars. Invisible streams of cosmic rays travel endlessly, high-energy particles born from distant explosions. They move through the galaxy like whispers through deep water, unseen yet ever-present. When they reach our solar system, Earth's magnetic field and atmosphere shield us from most of their intensity, but some slip through, leaving faint traces in detectors and in the upper air. Each one is a messenger from far away, perhaps from a supernova, a quasar, or the swirling disk around a black hole. Their journey lasts millions of years, crossing regions of magnetic turbulence and calm alike. To the human eye, they are nothing, yet their presence proves that even across vast silence, energy still flows. These ghostly travelers connect every corner of the Milky Way, carrying the galaxy's heartbeat through invisible motion, a reminder that no part of space is ever truly still. In the grand sweep of the Milky Way, we are small but perfectly placed. Our solar system orbits within a stable region, balanced between the chaos of the core and the quiet of the outer halo. Here, radiation is gentle, gravity steady, and conditions right for life to emerge. We exist in what astronomers call the galactic habitable zone, a cosmic temperate band. From this vantage point, the galaxy stretches around us in every direction, luminous, yet far enough away to admire without danger. It's easy to feel insignificant beneath such vastness, yet our position allows us to see and understand the whole like a single note in a great symphony. Our world's smallness is what gives the melody scale. We are neither center nor edge, just perfectly placed in the middle of the Milky Way's quiet turning. The Milky Way is not motionless in space. It sails quietly toward the constellation Leo, carrying everything we know along with it. This drift is invisible to our senses. Yet every star, planet, and cloud in our galaxy shares the same direction of travel. The movement is guided by gravity on a colossal scale, drawn toward dense regions of matter far beyond our sight. From Earth, we cannot feel it, but the background of the universe, the cosmic microwave glow, reveals our motion as a faint shift in temperature, a Doppler whisper of speed and direction. Our home galaxy glides through this stillness with purpose, cutting through space like a ship through calm water. If we could watch from afar, we would see the Milky Way drifting through the night of eternity, a luminous island crossing an ocean of silence toward a destination written in gravity. The Milky Way travels at nearly 600 kilometers per second relative to the cosmic background, a motion so fast it defies imagination. At that speed, our galaxy covers more than 2 million kilometers every hour, and yet to us, it feels perfectly still. This speed isn't chaos but harmony, the result of countless gravitational tugs from clusters, quasars, and invisible matter. The cosmic microwave background, a relic of the universe's birth, acts as a reference frame, revealing our direction through the faintest color shift, slightly warmer ahead, slightly cooler behind. Astronomers call this the dipole anisotropy, a subtle fingerprint of motion. Though the number is staggering, it's not alarming. Space itself moves, expanding and flowing. The Milky Way's flight through the cosmos is smooth and timeless. Its momentum, a quiet inheritance from the universe's beginning, a gentle reminder that even in stillness, everything drifts onward, far across the cosmic sea. Another great spiral glides toward us, the Andromeda Galaxy, our nearest large neighbor. Every day, it draws a little closer, pulled by gravity's slow insistence. The two galaxies are bound together, destined to meet in about 4 billion years. From our view, Andromeda appears as a faint smudge in the night sky, yet it contains more than 1 trillion stars, each on its own journey toward ours. When they finally converge, the collision will not be violent but graceful. The vast distances between stars mean most will pass without ever touching. Instead, their shapes will stretch and merge, creating a new, larger galaxy filled with fresh light. That future union reminds us that even cosmic separations are temporary. What drifts apart may someday reunite, and the spaces between worlds, though endless now, are only pauses in a dance that never stops. The Milky Way belongs to a small community of galaxies known as the Local Group, a family of about 50 members bound together by gravity. This collection includes giants like Andromeda and smaller companions such as the Magellanic Clouds, the Triangulum Galaxy, and dozens of faint dwarfs. Together, they form a cluster roughly 10 million light-years across, moving as one through space. Within this family, gravity is both bond and boundary, shaping each orbit and interaction. The Local Group drifts through the larger structure of the universe, a filament of galaxies connected by invisible threads of dark matter. From a great distance, it would look like a constellation of glowing islands suspended in infinite night. The Milky Way is just one voice in this quiet chorus, harmonizing with its neighbors across time. Their shared motion, a cosmic waltz older than memory itself. Their gravity binds them in a motion so slow it feels eternal. A waltz that will last for billions of years. The galaxies within the Local Group move around one another, drawn together by mutual attraction, yet balanced by distance. The Milky Way and Andromeda lead this cosmic dance, circling ever closer, while smaller galaxies weave between them like partners in a grand, unhurried ballet. Space between them may appear empty, but it hums with invisible tension, a field of energy that keeps the rhythm steady. Each orbit, each drift, adds to a pattern that has no beginning and no end. To watch it unfold would be to see time itself moving in spirals, galaxies gliding across the void with silent grace. Gravity is their music, patience their tempo, a dance written in starlight and carried through the dark for all eternity. The Milky Way's movement through space leaves delicate fingerprints on the oldest light in the universe, the cosmic microwave background. This ancient radiation, left over from the Big Bang, is almost perfectly uniform, but our galaxy's motion through it creates tiny distortions, like ripples in calm water. Scientists map these faint variations in temperature to trace our direction and speed, revealing that the Milky Way is gliding through the cosmos at hundreds of kilometers per second. The pattern is so subtle that it's measured in microkelvins, yet it carries the signature of our galactic voyage. These faint imprints show how even light from the universe's infancy still interacts with us, proof that nothing moves unnoticed. The Milky Way's drift across this ancient backdrop becomes a silent dialogue between past and present, a reminder that our galaxy's story is written into the very glow of creation itself. Across the Milky Way's sky, faint streams of stars stretch like threads of memory, marking where smaller galaxies once collided with ours. These stellar rivers are the remnants of tidal forces, gravity tearing apart entire systems and scattering their stars across space. Each stream follows the path of its vanished parent galaxy. A ribbon of light winding through the halo, astronomers trace their arcs to reconstruct the Milky Way's long history of mergers. Like archaeologists studying fossils in motion, some streams wrap around the galaxy completely. Others fade into darkness, their stars gradually blending with our own. What appears as calm starlight is actually evidence of ancient encounters, recorded not in words, but in the quiet motion of suns. The Milky Way grows by absorbing these smaller companions, weaving their remnants into its body, turning collisions into continuity, a cosmic memory preserved in drifting light. The Sagittarius dwarf galaxy, one of our nearest neighbors, is still merging with the Milky Way even now. Once a small, self-contained system of stars, it has been stretched and torn apart by our galaxy's gravity. Its remains form vast arcs of stellar streams wrapping around the Milky Way, their faint glow tracing its slow descent into absorption. This process has taken billions of years, a quiet blending rather than a violent clash. As the Sagittarius dwarf fades, its stars become part of our halo, enriching the Milky Way with new material and momentum. Telescopes can still detect its core, dim and distant. Orbiting below the galactic plane, each pass draws it closer until the last remnants dissolve completely. This ongoing merger is not destruction but renewal, one galaxy folding gently into another. Proof that even in the universe, endings are simply transformations in motion. The Milky Way's shape is not an accident of gravity, but a record of its entire history. Every collision, merger, and passing encounter has left its marked distortions in the spiral arms, ripples through the disk, and subtle warps along the edges. These scars reveal how the galaxy grew, consuming smaller systems and reshaping itself over billions of years. The faint halo that surrounds us carries the debris of those long-vanished companions, their stars now blended into our own, like rings in a tree. The Milky Way's structure preserves time, each layer a memory of change. Even its gentle tilt and uneven arms are echoes of ancient interactions, frozen mid-motion. To study its form is to read its autobiography, written not in words, but in orbits and light. The galaxy remembers everything, every brush, every drift, holding its entire past within its graceful spiral. Drift in the universe is not disorder, it is rhythm, the steady breathing of creation itself. Galaxies move, merge, and reshape in endless cycles, each motion guided by balance rather than chaos. Gravity pulls, inertia releases, and together they form the pulse of the cosmos. Stars are born, to burn, and fade, their ashes seeding new generations that begin the pattern again. The Milky Way's slow glide through the cosmic sea mirrors this eternal cadence, a movement so vast it feels like stillness. To call it chaos is to mistake scale for confusion. What we see as drifting is the universe exhaling a continuous cycle of expansion, interaction, and calm return. From the smallest particle to the largest cluster, everything participates in this quiet rhythm. The cosmos does not hurry, it breathes endlessly, reminding us that peace and motion are one and the same. Scattered throughout the Milky Way are stars, so ancient they predate our galaxy's spiral shape. Survivors from the universe's youth over 13 billion years ago. These stellar elders burn faintly now, their fuel nearly gone. Yet their light still reaches us after traveling across cosmic history. They formed soon after the first atoms cooled from the Big Bang's fire. When hydrogen and helium were almost all that existed, their existence is a window into the earliest era, when gravity first gathered matter into glowing spheres. Some of these stars still drift quietly through the halo, their orbits wide and slow, untouched by the turmoil of younger generations. To gaze upon one is to look backward in time, seeing not just a point of light, but a living fossil of the cosmos. In their dim persistence lies proof that even ancient fires can burn with quiet grace forever. These ancient suns belong to what astronomers call population, 2 stars, celestial elders that contain almost no heavy elements. Their simplicity reflects the chemical purity of the early universe, before generations of supernovae enriched space with carbon, oxygen, and iron in their atmospheres. Scientists detect only traces of these elements, tiny clues revealing when and how they were formed. They are nature's first draft of starlight, built from the universe's original ingredients. Studying them helps us understand how the cosmos evolved from simplicity to complexity, how dust and gas became the building blocks of life. Their scarcity of metals makes their light crisp and unfiltered, a pure signal from creation's dawn. Each one glows like a quiet teacher from the past, whispering of a time when stars were newborn. The universe was clear, and the only colors that existed were the raw hues of beginning. The oldest stars were born when the universe was dark, simple and vast, before galaxies had taken form. When only cold clouds of gas drifted through space, gravity slowly gathered those atoms together, igniting the first lights to pierce the cosmic night. In that moment, darkness ceased to be empty. It became alive with radiation. These early stars were enormous, burning fast and bright, living brief, violent lives that ended in supernovae, seeding the universe with the first heavy elements. Their descendants, smaller and longer-lived, still shine today within the Milky Way. When we observe them, we glimpse that first transition from silence to light. When the cosmos learned to glow, every flicker from those ancient suns carries an echo of that awakening, a message from the universe's childhood that even in the deepest dark, the instinct to shine is eternal. Many of the oldest known stars orbit not within the Milky Way's spiral arms, but far beyond them, in the halo surrounding the galaxy, out there, in near solitude. They travel slow, elongated paths that can take hundreds of millions of years to complete. These stars have watched the galaxy grow from a chaotic swarm into its current graceful form. They move through a region almost devoid of gas, where creation has long ceased. Yet their endurance keeps the halo glowing faintly. Astronomers track their positions to study the Milky Way's mass and history, their orbits acting like threads, tying the present to the beginning. Each one follows a different rhythm, a quiet pendulum swinging through time. Their journeys remind us that age does not mean stillness. Even the oldest light still moves, carrying memory through the silent architecture of the galaxy. Every ancient star carries within it the chemical fingerprints of the early cosmos, subtle ratios of hydrogen, helium, and trace elements that tell a story older than our world. By analyzing their light through spectroscopy, astronomers decode these patterns, discovering which elements were forged in the universe's first furnaces. Each spectral line is a signature, revealing how matter evolved from simplicity into richness. Some stars show the faintest hints of heavier metals, evidence that they were born from gas, touched by the earliest supernovae. Others remain almost pristine, unchanged since the first moments after creation. These chemical fingerprints are the universe's diary, written not in words but in light. Through them, we learn that every atom in our bodies, every drop of iron, calcium, and carbon was born in stars like these. Their glow is more than illumination. It's remembrance written across eternity. The light from these ancient stars began its journey long before Earth or the Sun existed. For billions of years, it crossed the expanding fabric of space, untouched by time, until finally brushing against our planet's thin atmosphere. Each photon carries the memory of its origin, a fragment of the universe's earliest moments preserved in motion. When that light reaches our eyes, we are seeing not what is, but what was a window into a world older than our imagination can hold. The atoms that make up our bodies were still drifting as interstellar dust when this light first set out. Now it arrives like a soft echo from creation's dawn, proving that the past is not gone, only delayed. To look upon it is to witness time as it truly behaves, slow, graceful, and filled with the quiet persistence of everything that ever was. Telescopes wait in endless patience to catch that ancient light, gathering it photon by photon through mirrors and lenses polished to perfection. The journey each particle makes ends there, absorbed by detectors that translate its faint energy into color and form. These instruments are not just machines but time travelers, turning invisible whispers into images of the distant past. In their stillness, they reveal motion, the slow unfolding of galaxies, the first sparks of stars, the architecture of cosmic dawn. Some photons they collect have traveled for more than 13 billion years, crossing unimaginable distances to be captured in a single instant. Through them, astronomers can reconstruct the universe's early history, frame by frame, across eons. Telescopes do not rush, they simply wait, absorbing light that never hurried either. Together they remind us that discovery is not speed, but the art of listening to time. Studying this light reveals the story of our beginnings, written not in ink, but in the faint signatures of distant radiation. Each beam carries information about temperature, motion, and composition, a code that, once deciphered, describes the birth of stars, galaxies, and even the elements that built us. Astronomers act as translators of the cosmos, turning these subtle traces into knowledge. By analyzing how the light has stretched over time, we learn how the universe expanded and evolved. Every color, every shift, is a syllable in the language of creation. What began as chaos became pattern. What began as darkness became understanding. The same physics that shapes galaxies also shape the atoms in our bones. To study ancient light is to read our shared origin story, one that started in silence, but continues to glow softly in every corner of the sky. In the presence of ancient starlight, time feels almost tangible, something you could hold if you reached out slowly enough. These photons have crossed epochs and collisions, outlasting everything they once illuminated, yet they remain unchanged. When they finally reach us, they carry not only distance but duration. We perceive them as light, but what they truly are is endurance made visible. Looking at them, the boundaries between past and present begin to blur, and you sense that time is not a straight line but a sea waves overlapping, moments folding into one another. In that stillness, The heartbeat of the cosmos becomes audible in its own way, through the steady rhythm of light, arriving after unimaginable years. The silence of space turns into texture, and for a moment, eternity feels close enough to touch. To see these ancient stars is to glimpse eternity, paused mid-breath. Their light, stretched thin by distance and age, glows with a kind of patience that words cannot match. Each point in the sky is a fragment of infinity, a frozen instant in a story still unfolding. The stars themselves may already be gone, their matter scattered into new forms, yet their light continues forward, carrying their existence across time. When you look up at them, you're witnessing the universe, remembering itself, holding a single moment forever. The sensation is quiet, almost sacred, a meeting between what once was and what still is. For a heartbeat, you are part of that pause, suspended between ages, aware that even the smallest flicker of light can hold the whole of forever within its glow. In roughly 4 billion years, the Milky Way and the Andromeda Galaxy will meet in a slow, cosmic embrace across the unimaginable expanse between them. Gravity is already pulling the two spirals toward one another, their motion steady and inevitable. For now, Andromeda is only a faint smudge in our night sky, but with each passing moment, it draws a little closer. When they finally converge, it won't be an explosion, but a dance lasting billions of years. Their shapes will stretch and twist, spiral arms unraveling into streams of stars that weave together like luminous silk. To any future observer, the sky will seem alive with motion, constellations shifting as the two galaxies entangle. That meeting will not mark an end, but a transformation, the next chapter in a story written by gravity, patience, and the quiet persistence of light across eternity. When the Milky Way and Andromeda finally collide, their stars will not crash into one another. Space is too fast. The distances between suns too great for such violence. Instead, they will drift through each other like ghosts, their gravitational fields warping and scattering the stellar orbits. New patterns will emerge, long arcs of stars, glowing bridges of light connecting both galaxies as they intertwine. Gas clouds, however, will collide, compressing into bursts of new star formation, igniting clusters that will sparkle against the dark. To a distant observer, it will look like slow choreography, a cosmic ballet unfolding in silence. Each pass will pull them closer until, after many billions of years, they finally merge. The night sky will change forever, yet the harmony of motion will remain, proving that even collision in the cosmos follows its own graceful rhythm. As the two galaxies approach, the night sky will bloom into something no human has ever seen, a double galaxy stretching from horizon to horizon. Andromeda's spiral arms will grow brighter each million years, swelling into view until they dominate the heavens. Stars from both galaxies will scatter across the firmament, creating a sky ablaze with distant suns. The familiar constellations will vanish, replaced by rivers of light and swirling clusters that move perceptibly over generations. The moon will pale beside this spectacle, its glow lost in a tapestry of countless stars. For any life that might remain, the sight will be both humbling and beautiful, the universe revealing its scale in the grandest way. What appears as cosmic upheaval is simply change at its most magnificent, a reminder that the heavens, too, evolve in their own slow, eternal rhythm. After the galaxies pass through each other again and again, they will begin to merge completely, forming a single, immense elliptical system. Their spiral arms will dissolve, stretched by gravity into streams that wrap around a new, unified core. Over billions of years, their combined mass will settle into balance, creating a smooth, rounded shape glowing with the light of trillions of stars. Star formation will slow as gas clouds are consumed or expelled, leaving behind a calmer, older galaxy. Astronomers believe this is the natural destiny of most large spirals to merge, evolve, and transform. The result will not be destruction but rebirth, a new harmony born from convergence. Though the Milky Way and Andromeda will lose their individuality, their essence will continue, intertwined forever in a single structure of luminous calm drifting through intergalactic night. Astronomers already have a name for this future union: Milky Way, the reborn galaxy. It will be larger, brighter, and rounder than either of its predecessors, a monumental fusion of light and memory. At its center will reside a supermassive black hole even greater than those that once anchored the two spirals, glowing softly with the energy of captured stars and gas. Around it, billions of suns will trace new orbits, their paths reshaped yet harmonious. From within, any remaining worlds would see a sky dense with stars, the night forever luminous, though the Milky Way as we know it will vanish. Its legacy will endure every star, every atom, every trace of light, finding a place in this new creation. Milky Way will drift on in serenity, proof that in the cosmos, endings are simply transformations waiting to shine anew. At the heart of the merging galaxies, their supermassive black holes will begin to spiral toward one another in an immense silence. Each orbit will draw them closer as they lose energy through gravitational waves, ripples in space-time that travel across the universe at the speed of light. For billions of years, they will circle like twin stars of darkness, their gravity shaping the paths of nearby suns and gas clouds. When they finally meet, they will merge in a burst of pure gravitational energy, unseen but profound. The resulting black hole will anchor the new galaxy's core, stabilizing its rotation and drawing stray stars into its balanced pull. Though no light will escape from that final union, its influence will ripple outward through eternity, a quiet reminder that even in the depths of shadow, the universe knows how to bring everything together again. As the Milky Way and Andromeda complete their union, the collision of their gas clouds will compress vast regions of interstellar material, igniting a final wave of star formation. Shock fronts from the merger will squeeze hydrogen into new stellar nurseries, setting off bursts of blue-white light that ripple through the forming galaxy. These newborn stars will burn fiercely but briefly, their brilliance lighting up the newly shaped heavens. Across billions of miles, clusters will bloom like sparks before slowly dimming. The process will reshape the galaxy's appearance, filling its core with fresh radiance before calm returns. This surge of creation is the universe's reflex, a breath of renewal following upheaval. Long after the dust settles, those young stars will mark the moment of transformation, a celestial memory of the time when two galaxies collided. And from their meeting, a new generation of light was born. When all the motions settle and the new galaxy stabilizes, the universe will keep its balance quietly, as it always has. The forces that guided every collision and every orbit will continue their steady work, maintaining harmony across distances too vast for measure. Gravity will hold the stars in place, Radiation will drift outward, and the cosmic web will keep its subtle tension. To us, it may seem like an ending, but to the universe, it's simply equilibrium energy finding its calm after motion. The merging of galaxies will not disturb the greater pattern. It will blend seamlessly into it, as though it had always been destined to happen. Even after billions of years of movement and change, the cosmos will remain composed, serene in its vastness. Balance is its nature, patience its law, and through it all, every transformation resolves into quiet, perfect order once more. For a while, after the great merger, the sky will glow brighter than ever before. The combined light of trillions of stars, new and old, will fill the heavens with brilliance beyond imagination. The galactic core will blaze, starburst regions will shimmer, and cosmic dust will catch the radiance like mist lit by dawn. It will be a golden age of light, a brief flowering in the life of the universe. Yet slowly, inevitably, the glow will begin to fade. Stars will exhaust their fuel, their brilliance dimming one by one. The galaxy will soften into calm again, its youthful energy replaced by deep, enduring quiet. This cycle of brightness and rest mirrors all existence, from stars to hearts. The light does not die, it only spreads thinner, turning into memory that continues to travel forever through the dark. In the end, there are no true endings, only transformations, so gentle they look like rest. The universe never stops, it simply changes rhythm. Galaxies collide and merge. Stars ignite and fade. Light shifts to longer wavelengths until it becomes warmth instead of flame. What seems like stillness is just motion slowed beyond perception, the eternal drift of creation reshaping itself in silence. Even when the night grows faint and cold, its energy remains. Recycled through time, every death becomes foundation. Every loss, a new beginning. The cosmos teaches us through example, endings are illusions, transitions written in light. When we look up at the Milky Way and imagine its future, we are seeing our own story reflected. That change, though vast and unstoppable, is always kind. And even in darkness, everything continues to move toward calm. At the farthest reaches of the Milky Way, the glow of stars begins to thin until it dissolves completely into intergalactic night. There is no clear boundary, only a gradual fading of light clusters giving way to isolation, motion giving way to quiet. Beyond the spiral arms, dust and gas vanish into darkness, and gravity's hold grows faint. Here, the galaxy's voice lowers to a whisper, its stars few and far between, like lanterns drifting on an endless sea. This edge is not an end, but a horizon, the place where the known softens into mystery. From this outermost veil, the Milky Way's light travels outward forever, merging with the ancient radiance of the universe. To reach this place, even in imagination, is to understand solitude not as emptiness, but as space wide enough for everything to exist, silent and undisturbed beneath eternity's deep breath. Beyond the dim outline of our galaxy lies the vast cosmic web, a structure of thin, glowing filaments stretching across the observable universe. Each thread is made of countless galaxies bound together by gravity, tracing a pattern that resembles the neural network of a living mind. Between these threads are immense voids, regions almost empty, yet perfectly balanced. The web is the architecture of existence itself, connecting every cluster, every star, in an unseen lattice of motion. When astronomers map it, they see not randomness, but rhythm, a geometry older than time. It's a reminder that the universe is not chaos scattered through nothingness, but an elegant structure where every part belongs. The Milky Way is just one glimmer in this vast network, a single note in a cosmic symphony woven through light and distance, harmonizing quietly with trillions of unseen worlds. The space between galaxies is not truly empty, it is simply waiting. It holds faint traces of atoms, particles, and radiation that drift endlessly through its expanse. The density is so low that light years might pass before a single atom encounters another. Yet even here, the universe breathes. These vast spaces act as the connective tissue of creation, linking clusters across unimaginable distance. In this stillness, energy flows invisibly, balancing the push of expansion with the pull of gravity. What we call nothingness is actually potential to a vast reservoir of quiet energy. The silence here is complete, but never dead. It hums faintly with the background of everything that has ever been. To imagine this space is to feel time stretch thin, to realize that the cosmos is not empty but patiently full, a canvas stretched endlessly, waiting for light to pass again. Between the galaxies drifts the intergalactic medium, a faint haze of atoms and ions that carries the ashes of stars long gone. These are the remnants of supernovae scattered carbon, oxygen, and iron drifting through the void. Though invisible to the naked eye, their presence is revealed in ultraviolet light, subtle signatures etched across the spectrum. They tell the story of matter's persistence, how nothing in the universe is ever truly lost. Even when stars die, their elements wander, waiting to be gathered again into new galaxies, new suns, perhaps new worlds. This diffuse sea connects everything that has ever shone. In it, the universe recycles its memory, transforming endings into beginnings too slow to see. The intergalactic medium may seem lonely, but within it lies the quiet continuity of all things, a whisper of starlight still traveling, still becoming forever. Through this vast, silent gulf drift cosmic rays, high-energy particles born in violent places. Now softened by distance and time, they come from ancient supernovae, black holes, and galaxies far beyond our own, crossing millions of light-years without slowing. When they reach our corner of the universe, they are faint, almost undetectable, but they carry the imprint of their origins. Each particle is a traveler, a story told through energy rather than words. They remind us that even in stillness, motion never ceases, even in silence. Messages continue to move. These rays cross the universe, like thoughts in a dream, weaving connections between distant worlds. Their journey may last longer than stars themselves, yet they persist, bearing proof that the cosmos is alive with unseen dialogue. In their endless drift, the universe keeps whispering to itself, a quiet conversation carried forever through the dark. The Milky Way is not alone in its voyage. It drifts as part of something far larger, the Laniakea supercluster. This immense structure spans more than 500 million light-years and contains over 100,000 galaxies, each moving along its own path, yet bound within the same gravitational basin. Laniakea means immense heaven, and it is an apt name, for within its reach Rivers of galaxies flow toward a shared center of gravity known as the Great Attractor. The Milky Way is one of countless luminous droplets in this vast current. Though we can't see the boundaries, their presence guides our motion through space. Every spiral, every cluster, every glimmering point of light belongs to this immense web. The supercluster is not a static object, but a flow, a majestic migration of galaxies drifting together through cosmic time. An ocean of light, moving in perfect, quiet harmony. Our galaxy's motion follows invisible gravitational rivers, streams of attraction that pull it through the fabric of space. These currents are shaped by regions of higher density clusters, dark matter, filaments, and ancient voids guiding every galaxy like a leaf caught in a cosmic tide. Though we cannot see the forces directly, their influence is unmistakable. The Milky Way glides along one such river toward the Great Attractor, carried by the sum of countless gravitational whispers. The flow is smooth, not hurried, the result of delicate balance between expansion and pull to the human eye. This motion is imperceptible, yet it defines our place in the universe. We are passengers in a vast current that began billions of years ago and will continue long after us. Through these unseen streams, the cosmos reminds us that every movement, no matter how small, is part of something infinite. Even in what seems like vast emptiness, the universe reveals a quiet order, a geometry written in gravity between galaxies. In the deep dark, matter arranges itself into delicate filaments and nodes, forming a cosmic skeleton that supports all creation. This structure is subtle, invisible to ordinary sight, but its presence shapes everything we can see. Gravity threads through it like a loom, drawing galaxies together into patterns too vast for comprehension. There is no randomness here, only the appearance of it from our limited view. When seen from a greater distance, the universe becomes symmetry in motion, waves of matter expanding, colliding, and balancing in perfect calm. The spaces between stars, between galaxies, are not disorder, but design. The stillness between the beats of creation's pulse. Even the quietest corner of the cosmos obeys this hidden rhythm, an eternal harmony that keeps everything gently aligned. Long after our species is gone, long after the Earth has cooled and faded, light will keep traveling. The photons leaving our galaxy tonight will cross the void for billions of years, carrying with them the imprint of the Milky Way's glow. They will pass through superclusters and emptiness, their energy slowly stretching with the expansion of the universe. But they will never truly stop. Light is persistence made visible, a promise that even the briefest flash endures somewhere. Every candle, every star, every reflection adds to that quiet ocean of radiance, moving outward forever. To imagine this is to find peace in impermanence. Though everything changes, nothing truly disappears. The glow of what once was continues on, painting the future with memory. In that endless travel of light, the universe keeps remembering itself soft, steady, and eternal. Somewhere in that endless night, the Milky Way keeps breathing slow, patient, and alive in its own rhythm. Stars are born and fade, clouds adrift. Gravity hums its steady tone. Across billions of years, the galaxy inhales and exhales light. Expansion and stillness entwined like sleep and waking. That rhythm exists in everything, in the turning of planets, the beating of hearts, the rise and fall of breath. The cosmos is not distant from us, it is within us, reflected in every pulse and silence. When you breathe now, you mirror the galaxy itself, calm, cyclical, infinite. The same atoms that once burned in ancient stars move through you tonight, glowing softly in your veins. So let yourself rest within that knowing. The universe moves, you move with it, and in the quiet between thoughts, you are part of its endless, luminous peace. Return now, softly, from the edges of the galaxy. You've drifted far tonight, through the spiral arms, past the halo, into the quiet sea of intergalactic dark. You've seen the Milky Way breathe, and in that rhythm, you might have felt your own breath follow. Every pulse of starlight you imagined still exists, crossing eternity, just as your thoughts move through the calm of this moment. You are part of that same gentle motion matter, memory, and light woven into the same cosmic thread. The galaxy will continue to turn long after this night, and its calm will remain. Stars will fade, others will bloom, and still the great wheel will move with patience. In this vast rhythm, there is no rush, no noise, no ending, only quiet continuation. You were never separate from it. You've always been within it, breathing alongside the Milky Way's slow exhale. As you rest, let your thoughts grow lighter, your body quieter, your awareness softer. Let each breath mirror the steady expansion of space. Inhale the calm, exhale the distance. The same atoms that drift between stars now rest within you, glowing faintly, perfectly at peace. You are made of the galaxy's dust, shaped by its light, carried in its endless current. If you can still hear the silence, stay with it a while. It's the same silence that fills the void between worlds, the same silence that holds galaxies in balance. It's not emptiness, it's harmony. You belong to that stillness. You always have. And when you're ready to sleep, imagine the Milky Way floating quietly in the dark, its arms unfolding like soft light across the night. Somewhere within it, Earth turns beneath the same stars. Small but shining, the universe continues to breathe. And so do you. If you'd like, you can leave a gentle comment before you drift away. Tell me where you're listening from tonight, and what time the stars are rising above you. It helps others find their calm among the constellations too. Now, let go. The galaxy will watch over you. Rest, and let the quiet of space carry you into dreams until the next dawn of light finds you again. Good night.